Hello everyone, welcome to my YouTube channel. I am Dr. Injamamul Haq, currently working as an assistant professor at the Department of Mathematics, School of Computer Science and AI, SR University, Warangal. Today I will discuss a lecture on correlation, an important concept in statistics that help us to understand the relationship between the variables. In this video, we will focus on simple correlation, particularly Karl Pearson correlation coefficient, which is widely used in data analysis. By the end of this lecture, you will understand the concept, interpretation, and calculation of correlation through the examples. So let us begin with the basic idea. First, I will define the correlation. So correlation is a statistical method used to measure the relationship between two variables. Okay, so it helps us understand how one variable is changing with respect to the another. So we will understand this definition with the help of some examples. So let x and y are two random variables representing the following. Okay, first one, advertisement advertisement and sales. Second one, price and demand of product and demand of product. Third one, income and expenditure. Fourth one, competition and sales in commodity. Okay, so we can see that on all these cases we are interested in knowing whether this variable move together or in opposite direction. That means if the advertisement is more, then the sales will be increased or decreased. If the price is high, then the demand of the product will be increased or decreased. If the income is more, then what will be the effect of expenditure, whether it will be increased or decreased. If the competition and sales in commodity, if the competition is high, then what will be the effect on the sales in commodity? It will be increased or decreased. So we are interested to knowing about these things. So a quantity measure of relationship between two variable is required to intercept the correlation between them. So that these are the examples of correlation, means we can relate these two variables. Okay, so this is all about the correlation. So now I will discuss about the types of correlation. So correlation can be broadly classified into three types. Correlation can be broadly classified into three types. Okay. First one is the positive correlation. What is positive correlation? When both random variables increases or decreases, right, together. Second one is negative correlation. Negative correlation. What is this? When one variable increases while the other decreases, right? Third one is the zero correlation. Zero correlation. What is this? When there is no relationship, when there is no relationship between between variables. Okay. So these are the type of correlation. Correlation are of three types: positive correlation when both the variable increase or decrease together; negative correlation when one variable increases while the others are decreases; and the zero correlation if there is no relationship between two variables. In that situation, you can say that there is a zero correlations. So, understanding the type of correlation help in interpreting the data effectively. So now we will discuss about the correlation in geometrical way. So one of the simplest way to visualizing the correlation is through the scatter diagram. So now we will discuss about the scatter diagram. So here each pair of the observation is plotted as a point on a graph. So if the points are closely calculated along the line, then we can say that the given variables are strongly correlated. And if the points are widely scattered, then we can say that the variables are weakly correlated. If the pattern slopes upward, here you can see that it indicates that positive correlation. If the slopes are downward, it indicates that the negative correlation. And if the scattered plot give us the visual understanding before we move to the numerical measures. So now here we can see that some scattering high and low degree correlation. If we can see that here the variable y and variable x, so this is actually the points are very closely related, so that's why here the high degree of negative correlation, and here the point are closely related, point are scattered and they're far away from each other, that's why this is low degree positive correlation, and here we can see that this is the low degree negative correlations. So this is all about the scatter diagrams but scattered plots give us to the visual understanding. So before we move to the numerical, so we have to know about the some numerical measures. So now we will study about how can we measure this as a numerically. And also there is one more graph related to the correlation. Actually these graphs really, give that there is no correlation. Why? Because here we can see that the variable y is increases but variable x is still at the same position. That's why this there is no correlation between x and y. Here also there is no correlation between x and y. In the last figure also show that there is no correlation between the x and y. So now these are the importance of the correlation. It helps in understanding the relationship between the variable, useful for prediction and forecasting, aid in decision making, form the base for the regression analysis, study hours and academic performance, attendance and exam result. It also helps to teaching method and learning outcome, advertising the expenditure and sales, income and consumption, price and demand and market trend analysis. So these are some importance of the correlations. So while scatter diagram are useful, they are not precious. So we need to numerical measure to quantify the strength and direction of the relationship, and this lead us to the concept of sample correlation coefficient. The sample correlation coefficient measure the degree and direction of linear relationship between two variables using the sample data. It tells us how closely two variables move together, and it is calculated from a simple note the entire population, and we will denote it by small r, and it is a statistics used to estimate the population correlation coefficient. So now we will discuss about the Karl Pearson sample correlation coefficient. So Karl Pearson sample correlation coefficient is the ratio of the covariance between two variables to the product of their standard deviation. That means we can write R equal to summation of x minus x bar. This is the x bar is the mean, and y minus y bar by square root of what? This is the standard deviation will be what? X minus x bar square into summation y minus y bar square. So this is the formula. This is the direct formula to finding the Karl Pearson sample correlation coefficient. So now we'll discuss. There is another formula which is shortcut formula. We can say that. So now I will discuss the shortcut formula to finding the Karl Pearson correlation coefficient. This is equal to R equal to n into summation of x into y into summation of x into summation of y by square root of n into summation of x square minus summation of x whole square. Okay. Similarly, we will write the same things for second variable n into summation y square summation y square minus summation y of whole square. Right. So this is the formula to finding the Karl Pearson correlation coefficient. Here n is the number of observation, n is the number of observation, x and y are the period of sample values, period of sample values, and summation x square y square is the sum of this is what summation x square comma y square, this is nothing but the sum of square of data, sum of square, and this is summation of x into y is nothing but sum of the product, sum of product. Okay, so this is the shortcut formula to finding the Karl Pearson correlation. So now we will discuss about the range of Karl Pearson coefficient. What is the range? Range of Karl Pearson coefficient lie between R is lie between -1 to 1. If R equal to if R equal to 1, then we can say that perfectly perfect sorry perfect positive correlation, perfect positive correlation. If R lie between 0 to 1, simply we can say that positive correlation. And if R equal to 0, then no correlation, no correlation. If R lie between -1 to 0, negative correlation, negative correlation. Okay. If R equal to -1, this is negative, perfect negative correlation. Okay. So now we will interpret of the simple correlation coefficient. Positive value means what? Positive value means variable move in the same direction, and negative value means what? Variable move in opposite direction. Value close to 0 means what? Weak or no correlation, and if value is close to ±1 means strong correlationship. So these are the interpretation of the sample correlation coefficient, and there are some properties of the correlation. Is what? The correlation coefficient is always unit free. Correlation coefficient is always unit free, that is there is no unit, and this is always symmetric, that is R of x y equal to R of y x. Okay, and this is the dimensionless. The Karl Pearson correlation coefficient is dimensionless. There is no dimension. So these are all about the interpretation of simple correlation coefficient. Now we will understand the Karl Pearson correlation coefficient by some numerical examples. Okay. So let us take an example. A teacher want to study the relationship between the numbers of R study and the marks obtained by a group of students. The data is collected given value. Here we can see that the study hours and the marks obtained are given in this question. We have to find the simple correlation coefficient. Then what about the interpretation of this result? Okay. So let us find it. So first I will make the table. This is X, this is Y, this is X square, this is Y square, this is X into Y. Okay, so we'll make the table first. Value of 2, X is 2, 4, 6, 8, 10, right? And corresponding value of Y is 5, 9, 13, 17, 21. So now we can find the value of X square is what? 4, this is 16, this is 36, this is 64, this is 100. Now what is the value of y square? This is 25, this is 81, this is 169, this is what? 289, and this is what? 441. Okay. So now we will find the value of x into y. This is what? 10, this is what? 36, this is what? 78, this will be what? 136, and this is 210. Now we will add all these value column wise. Then we will get the value of summation of x. This is equal to what? 30. Summation of y. This is equal to what? 65. This is what? Summation of x square. This is equal to what? 220. This is summation of y square 1005. This is what? Summation of x into y. This is equal to 470. So now we will have all the value summation of x, summation of y, summation of x square, summation of y square into summation of x, y. So now we will apply the formula to finding the simple correlation. Using Karl Pearson's correlation correlation coefficient formula. What is this? R equal to n into summation x into y minus summation of x into summation of y by n into summation x square minus summation of x whole square into n into summation y square minus summation of y whole square, right? So here n equal to what? Here n equal to, we can see that the total number of observation is 5. That's why n equal to 5. So now we will put all the value. N equal to 5. Summation xy is 470 minus summation of x is 30. Summation of y is 65, right? By this is equal to what? N equal to 5. Summation x square is 220. Okay, minus summation x whole square, that is 30 ka whole square. The whole square of 30, this is 900, right? And what's about the next one? 5 into 1005 summation of y square into summation y whole square is what? 4225. So now what is the value? Value equal to what? R equal to 400 by 400. This is equal to the 1. So hence there exists perfect r equal to 1, and already we have discussed about that. If r is equal to the plus 1, then there exists perfect positive correlation between the r study and marks obtained. Okay, that means if you focused on, if you give the more time on study, definitely you will get the good marks. So that's why there exists a perfect positive correlation between r studied and marks obtained. Marks obtained. Okay. So now come to the next problem. There is another example. An engineer record the speed of vehicles and the time taken to travel a fixed distance. The observation are as follow. speed and the time is given here. Here we have to find the sample correlation coefficient, then we have to interpret the result. Okay, so in the similar way I will make the table again. That will be what? First x, then y, then x square, then y square, then x into y. Okay, so this is what? 1, 2, 3, 4, 5, right? And corresponding to value of x, the y is what? 10, 8, 6, 4, 2. Now we will find the square of x. This is 1, this is 4, this is 9, this is 16, this is 25. And corresponding to y, the square of y is 100, this is 64, this is 36, this is 16, and this is 4. Now the value of x into y is equal to 10, 16, 18, again this is 16, and this is 10. Now we will add this value. Summation of x, this is equal to the what? 15. Summation of y equal to what? 30. Summation of x square, this is equal to 55. Summation of y square equal to 220. Summation of x into y equal to what? 70. So these are the table. Now we will apply the Karl Pearson correlation coefficient formula. R equal to what? N into summation x into y. So n here, n is equal to the 5, and summation of x y equal to 70, minus summation of x into y. Summation of x is what? 15, and summation of y is what? 30, by square root of n into summation of x square. So 5 into summation x square is 55, minus summation x whole square, that is 15 whole square, this is 225, into 5 into summation y square, summation y square, this is 220, minus summation y whole square, this is 900, right? So now we'll calculate this value. This will be equal to -1, right? So what things we get? If the correlation coefficient r is equal to exactly -1, that means this is perfectly negative correlation, means there is a perfect negative correlation between speed and time. Okay, so now we'll discuss one more problem based on sample correlation coefficient. A company studies the relationship between the year of experience and monthly salary of the employee. The collected data is what? Experience X is 3, 5, 7, 9. Salary is 4, 7, 10, 15. Then we have to find the simple correlation coefficient. Okay. So now again I will make the same table. This is what? X, Y, X square, Y square, X into Y. Okay. So this is what? 3, 5, 7, 9. This is what? 4, 7, 10, 15. This is 9, 25, 49, 81. This is what? 16, 49, 100, 225. This is what? 12. This is 35. This is 70. This is 135. Now we'll sum these x. Summation of x will be 24. Summation of y will be 36. Summation of x square is 164. If you add the summation of y square, this is equal to 390, and summation of x into y equal to 70. Now we will apply the Karl Pearson correlation coefficient formula. So what is R? R equal to n into summation of xy. Here n is equal to the 4. We can see that the total number of observation 4. That's why n equal to 4. So 4 into summation x into y. This is what? 252, right? Minus summation x. Summation x is what? 24. Summation y is what? 36 by square root of what? Square root of n into n means 4 into summation y x square. This is 164 minus summation x whole square is equal to what? 576 into 4 into what? 390. The summation of y square minus summation y whole square. Summation y whole square is what? 1296. So if we solve this, we will get the value approximate 0.99. Means what? Very strong positively correlation. This means there is a very strong positive correlation between experience and salary. Okay. So now we have understand the concept of simple correlation coefficient. Thank you. Then we will explain about the rank correlation coefficient in the next video. Thank you very much.